Intro: A brief scientist profile of Robert Andrews Millikan, the man who grew up to discover the charge of an electron and many other contributions, which later got expanded upon after his passing. Background: His first born in Morrison, Illinois, March 22, 1868. He later attended high school in Iowa. After graduating, he entered Oberlin College and majoring in classics. His scientific career proceeded to a fellowship in physics at Columbia University. His doctoral research concerned the polarization of incandescent light. In the same year, he was invited to join Max Planck and Walter Nernst in the University of Göttingen in Berlin. Returning to U.S. in 1896 to join A. Michelson at the University of Chicago, Millikan later married Irwin Blatchard in 1902, and their family grew, including 3 sons. Devoted to teaching, Millikan became full-time professor in 1910, establishing a curriculum and collaborating on many textbooks which stress laboratory-based learning and introductory physics at high school and college levels. On a personal level, this might be the greatest impact to me that he contributed to. Having laboratory-based learning during high school level physics is the greatest contribution for people that excels in hands-on learning. Millikan ended up passing away in his home at age of 85 in 1953 due to a heart attack. Even after passing, Millikan's legacy lives on through his best research, theories, and greatest discovery. Millikan facts. It was stated that he loved playing tennis and golf. His favorite subjects were Greek and mathematics, which is certainly interesting knowing the path he decided to later take on life. Part-time jobs he had were as court reporter right before entering Oberlin College, and also teaching for post-elementary physics for a period of 2 years after his graduation, where he really developed his interest for physics. The oil drop experiments devised by Millikan and his colleague Harvey Fletcher, one of his greatest feats, which led him to the discovery of the independent charge of an electron. Before Millikan's passing, he contributed to many different fields, including the atomic theory that his discovery allowed the Danish physicist Niels Bohr to calculate Rydberg's constant, and contributed to new atomic theories by showing its first and most important proofs. In addition, Millikan explored the photoelectric effect, where it showed that metals emit electrons when light is shown upon them, which we all learned in our most recent Unit 6. Having prior knowledge definitely helps further understanding this topic. This also demonstrated proof of Albert Einstein's equation, E equals mc squared. He also studied polarization of incandescent light waves, which the vibration occurs in a single plane, which we also covered in our Unit 5. It was all about light, vibration, and wavelengths. At Caltech, his research centered on cosmic rays, a term he invented to describe high-energy particles that strike Earth's atmosphere. Overall, his discoveries guided the later research of scientists all around the world. Discoveries. Through his discoveries of his oil drop experiment, Millikan was trying to find the charge of a single electron. Trying to accomplish this, he discovered many other things along the way. Oil drop experiment. Spraying tiny droplets of oil, then taking its measurement given to find the individual charge of an electron. To find the charge, Millikan put a charge on a drop of oil, then charged the 2 plate until he could stop the oil drop from dropping. First, Millikan used an atomizer to spray oil droplets into the chamber. These droplets would then fall through the hole and into the second chamber. Using a microscope, Millikan measured the mass of each oil by measuring its terminal velocity. Millikan then charged the oil droplets by filling the bottom chamber with X-rays, thus causing the air to become ionized, having 1 or more electrons removed, and letting the electrons attach themselves onto the oil droplet. Millikan also charged the 2 plates that separated the 2 chambers with a battery. He charged the top one positive and the bottom one negative. This way, the electrical force from above would balance the gravitational pull from below. This caused the oil drops to either stay elevated or even go up. Using the known strength of the electrical field, Millikan determined the independent charge of an electron of the oil drops to be 1.602 17657 times 10 to the power of negative 19 coulombs. This discovery was very important and impactful, since now anyone who works in the field of science or technology can utilize and make efficient use of this knowledge, such as the study of electromagnetic fields, something very delicate. Doing this experiment during class for our labs, it was certainly very different yet pretty similar. Luckily, we did not have to use an oil chamber device since the information was randomly generated through it, though it mimics how random real life electrons are. These trial and errors and recordings of all different data of oil droplets, I've learned, is the most important part where you cannot miss up. It was a great insight to learn the real process of Millikan, and I really hope you enjoy.